We live. I don't know. Hold on. Okay. The hell is going on here? Some funny business? Are we live? Are we live? So, a couple years ago, I wrote this library for hypergraphs, and I realized I want to rewrite this in Rust. And I already found a hypergraph Rust library. But this guy is doing all sorts of fancy stuff. He's using more than one file. Any programmer that uses more than one file, you know you should be a little suspicious. Because more than one file, they love it to be complex. They want the world to just bask in their glory. I don't know. But we don't do that here. We write one file for the project. That's it. That's the whole project. It's just a script. You just cargo run it, and it shows you what the library does. So we're not going to use this. I don't know how long this is going to take. I actually have done 2 hypergraph libraries. The other one used AC sets and used CatLab. And this one I never did rewriting on. So, there's also another library. I need to go to. By the way, freaking guys, check it out. Wait, is this going to show my email? Whatever, I think it's a dummy email. But we hit 100 subscribers. Thank you very much for the 100 subs. Chat, you know what to do. Dubs. All right, I'm. Anyways, the video that blew up, which was really funny, for me, is just this taking pictures video. I don't know what it is about this video that why it got to the right people, but one thing that's interesting, I was thinking about what is it that the YouTube algorithm does, and I feel like it tries to basically, once it's sort of figured out the demographic, the click-through rate, the average watch time, once those statistics are relatively accurate in their prediction, then it can basically stop, or this is like a first pass, and then it starts to send it to the demographic, but it's really interesting looking at these analytics and thinking about how does the YouTube algorithm actually work, because you could see since it had a higher click-through rate, it got suggested to more people, so it just reinforced itself, but it had a stable click-through rate. So basically what that means is it's not as it suggested it to more people, it drops to 0, because once it's getting out of its demographic of high likelihood of high click-through rate, then it should just kill the video. Anyways, that's what I was thinking about. So, but I don't know why this one did well. I don't think there's anything in there that's necessarily good, but I just wanted to go over that because it's probably a pretty interesting way that it weeds out videos. All right, so then the real library. How do I see my repositories? I don't know. Oh, it's up here. I wrote this before I wrote the other one. I probably just fixed the bug. Let's see. Graph helpers, hypergraphs, symbolics. That's nice. I probably don't even need symbolics. I think it's just for pattern matching. I hope we don't have to. Let's see. One file. I don't know why I didn't put this in the library. is equal hypergraph 1, hypergraph 2, you can, whatever. I think you could probably, so what we'll probably do in Rust, just do whatever. Ew, 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 ew. All right. Oh yeah, I tried to get a Discord bot working, but it didn't work for the display, so that's too bad. Okay, so I think that this is going to be, do you have to say mute here? I don't even know. Let's see, does Copilot work? I feel like Copilot's always broken. Okay. Yeah, it could be anything. Who knows? Okay, so let's go to the hypergraph, because I don't want to use the answer. I have the answer right here. It's a vec of vec, and it's a vec of vec, and that's all it is. But I don't... You know what? But what it will help me is if I look at the test and see how I'd... Oh yeah, I wanted to write this thing about the... This is a cool file, actually. I was thinking of, like, methods and currying and subtyping as, like, simplicial complices, whatever simplicial complexes, and I don't know if I ever really got this to work, but I wanted to take all of the types are vertices and the hyperedges are methods. Yeah, that's interesting because it's like, yeah, this is so cool. We should do this with Rust code. We should take some big ass Rust libraries and see if we can. I wonder if it's the same or if it even has that good of reflection tooling. Because the cool thing about Julia and Lisp is it's so dynamic that you don't have to compile it first. But maybe we could just interpret as it does a... Is there just like a Rust interpreter? It would be hard. This, I think... Is this just a JIT? I actually never really understood what evaluation context meant. For each code snippet, it makes a DLL. Huh. Why don't they... What is the equivalent? How good is Cling? I heard from the Julia people want to say Cling is Garbo, but if it's just for C, it might be cool. The thing is, not many people use it. I guess the debugging is good enough that you don't really need an interpreter. It's a 30-minute video, bro.
If I press Control Enter, it runs this film.
All right, I'm watching that. probably looked at that post before. Okay, so let's just go to hypergraphs. I remember the thing that always got me with the data structure for hypergraphs. I don't remember if this ended up being a non-issue, but what I remember is that for rules that eliminate, or for algorithms that eliminate nodes and edges, that that keeping everything contiguous, or like referencing the right vector with indices, was a little bit challenging, but I don't exactly remember. Anyway, so hypergraph is a really simple thing overall. Should I just go to this? This doesn't have the hypergraph. I mean, honestly, we want graph rewriting, and I actually want whatever. Let's just read this. Yeah. I'm just curious what. Why is everything a struct? I don't like that, dude. Just give me ints. Over abstraction, bro. Okay, a hyperedge is just a set of, yeah. Maybe you do want to just keep them as hash sets. What was the actual solution for me? Did this ever work? It's kind of lame. I don't think I actually I don't remember if I dude, I love that now, 2 years later, I can just ask these questions. Yeah, in traditional graph theory, the Cartesian product of two graphs is a graph where the vertex set consists of all ordered pairs. So you get, okay. I love this picture. Wait, those are two different blues. I don't like that those blues are so close together. Dude, this is very confusing. Okay, so dark blue and brown form a vertex, and so does light blue and brown. Does this mean when they say two vertices are adjacent, that means that defines the edge set, right? Yeah, let's get an example. Cartesian product of two edges gives you a cycle. All right. In the shade, so I won't get sunburned, so I can take off my shirt. I love the sun. I wish I could just withstand the sun. Oh my gosh, I really did that this whole time? That sucks. Okay, what did we go over? That sucks. That's a big L, bro. That's a big L. Okay. I just want to look at an example of a hypergraph. Let me just figure this out. So, this is the rewriting. Yeah, I can't handle more than one edge on the left-hand side. I don't care. Can't decide. Can't decide. Okay. So here's the hypergraph library. Contains the list of hyperedge indices that include V as a vertex. Vector to hyperedges. Okay, so the hyperedges are indexed, and so for the first element of this, and why was that the design? I don't know if I came up with this on my own. I wish I was streaming that. And I could just like go ask and check. Contains the list of indices to in here that include V as a vertex. Let me get a notebook. Yeah, I'll get a notebook. Huh. I don't know about all that. Oh, shoot. Okay. So let's just get an example of a hypergraph. Let me look at that picture. Okay, so let's just draw this picture down as the structure. It's so hype. I was looking through my old notebook and I stumbled on this hypergraph stuff, and it's like, bro, I need to do that again because that was such a fun project. Man, I love graph theory. All right, so we have let's just say the vertex set is 1 to 7. Okay. Then the E set is there's 4 edges. Okay, so we're gonna have in the first list here, let's see, where were we? This contains the list. Okay, so first off, let's just do this, which is, this is, okay, so this is the structure. So let's just say we have the empty hypergraph with like one vertex. Then it should just be a list of okay, so okay, so the empty hypergraph. Wait, can we just derive everything? Debug, clone, eq, hash. I love that, dude. Okay, I don't know about all that. Is that how you do it? The fuck, bro? That's not right. I think it's that. Okay, that seems fine. So this answers the question. Do you do triple? I don't know if you do triple, but this is has length and NV, and it answers, and for each element answers the question which indices into HE to V have my index. That's basically it. So the empty hypergraph, the hypergraph with 2 vertices and 0 edges looks like um Can we just use this thing? Okay, so if we go here, will it print? All right, I'll probably load forever. Oh, we need to do this. Oh, wait, it's not gonna, is it gonna know? I don't think I ever registered that. In the manifest, do I say a get ha? Probably. It probably works. Okay, so let's see if this works. Let's just try to call update. What? Dude, this is what I'm saying, bro. Come on. Just fail already so I can update. Okay, this is ridiculous. Dude, if this compat... Oh, you gotta be fucking kidding me. Dude, I don't get why this is so bad. Okay, it didn't look like there's any breaking changes, so maybe we'll be okay. Okay, I'm just gonna... Okay, what do I expect this to look like? It has... So this will be... So that means that this should be... So that means that we should have... Oh. So example, no edge to V graph is that. And then we have this. Okay, but then when we add a graph or an edge, yeah, 0, 1, then we have one, or, oh, should we one index this? One indexing is clearly superior. I guess in this case it's 0. So we're gonna have V2HE is 0, 0, and then okay, cool. I basically just wait for it to come back. All right. So, this is gonna look like, yeah, that's exactly right. So this is like the simplest way you could possibly think of doing a hypergraph. Is you say, but technically this is all you need, because what you could do is you could this is technically all you need to actually describe. Well, that's not exactly true, because there could be vertices, like in this case, that have no edges. So you need to know how many vertices are there from this. Okay, so that all makes sense. So let's just say, I don't know what the way to do this is, because the way that I implemented this in, okay, you know what? We're just gonna say, okay, that's fine. Oh, perfect. Wait, why does it need to be that? Should we just do U size? Then we can get rid of some of this random crap. Okay, so that's probably right. Let's see. Uh, the edges are a vec of, yeah, collections of vertices. And then for each one, you just call that. That's makes sense. And then let's see if this logic is right. Add an edge. To add an edge, you also have to iterate over all of these guys to let them know that they're in that. V2HE. And HE is going to be a U size. I'm guessing this indexing is correct. I just wish it was one based. Okay, so then you... Okay, perfect. So we're all good. I love it. Okay, so was that what we expected? Yes, it was. So then... Perfect. Perfect. So that's all you need to represent hypergraphs. Naturally, it's a very simple data structure. So the question now is we can finally go to Tarzan, bro. I'm getting fucking built, dude. I've been going to the gym, man, and it feels amazing. You know, we're all into gym and we're just there having a good time. Okay. Oh, what did I just close? I just closed it. Okay. That was not so bad. So now, dude, think what we did in 50 lines of code. This guy did. I mean, he obviously does way more, but what I'm saying is it's complicated. What is that program to count the lines of code? What's that tool that counts line of code and estimates the cost? It's called like, it's not clock. There was a new one. No. Names some clock alts. Dude, no, I'm only like a week into it. I'm trying to remember. Was it clock? I thought clock. Oh, God. Wait. SCC, bro. That's what I was thinking of. Scoop? Do I even have Scoop? Oh, I have Chocolatey. Winget SCC. Bro. Whatever. Whatever. Oh, yeah. Do I have to do that? So close this and then open it as admin. Oh, why did I press the wrong thing? Okay, wait. Do we have the terminal now? So I can now... Oh, wait. I didn't even have to put in my... I did not have to do that. Whatever. Yes, come on, bro. What? Do you want to run the script? Probably. God. All these tools, Scoop, Chocolatey, Winget, they're all freaking annoying. What? I never cloned Cast 3 onto here. That's kind of crazy, actually, that I haven't. Dude, Brew is good. I don't know. Okay, Brew's a little slow, but Brew is very good. The thing is, I think Brew actually works on Windows too. No. Brew doesn't work on Windows. Brew works on Unix systems, so it works on Linux too. But I feel like there was like some weird support with that. Like it's not as good as Apple, but all right. So let's go to Gamepad and let's SCC. 3,000 for this, dude. I wish someone would. I wish someone would give me $3,000 for a little gamepad application, so you can control your computer. Anyways, so that's SEC. So let's go back to now that we have SEC, we can go. So Chocolatey did work, but it's just like Windows is garbage. Oh wait, we wanted to go to right. Yes, so there's, oh wait, there is 4,000 lines of code. It took 50 lines of code. Code complexity. Yeah, you want to see my code complexity, bro? Bam. Code complexity 3. It's a data structure and a couple of methods. Okay. So now we're going to, let's see. Should I read the introduction? I'll read the introduction. That sounds fun. Quantum mechanics and general relativity, both introduced more than a century ago, have delivered many impressive successes in physics, but they've not allowed the formulation of a complete fundamental theory of our universe. And at this point, it seems worthwhile to try exploring other foundations from which space-time and general relativity, quantum mechanics, and all the other known features of physics could emerge. The purpose here is to introduce a class of models that could be relevant. The models are set up to be as minimal and structureless as possible, but despite the simplicity of their construction, they can nevertheless exhibit great complexity and structure in their behavior. Even independent of their possible relevance to fundamental physics, the models appear to be of significant interest in their own right, not at least a source of examples amenable to rich analysis by modern methods of mathematics and mathematical physics. Yeah, I was thinking like about dynamics on hypergraphs. Like if you have Lotka-Volterra predator-prey models, like can you just use rewriting to add species? I don't know, something weird like that. But what is potentially significant for physics is that with exceptionally little input, the models already seem to be able to reproduce some important and sophisticated features of known fundamental physics and give suggestive indications of being able to reproduce much more. Our approach here is to carry out a fairly extensive empirical investigation of the models and then use the results of this to make it. Okay, dude. Let's see. All right, I'll keep reading it. If this stream wants to go as long as it can. Our approach here is to carry out a very extensive empirical investigation of the models, then use the results of this to make connections with known mathematical and other features of physics. We do not know a priori whether any model that we would recognize as simple can completely describe the operation of our universe, although the very existence of physical laws does seem to indicate some simplicity. But it is basically inevitable that if a simple model exists, then almost nothing about the universe as we normally perceive it, including notions like space and time, would fit recognizably into the model. That's actually a good point. I'm glad I read that. I didn't think about that. And given this, the approach that we take is to consider models that are as minimal and structureless as possible so that, in effect, there's the greatest opportunity for the phenomenon of emergence to operate. Bro, Stephen Wolfram's just on another plane. The models introduced here have their origins in network-based models studied in the 1990s. Okay, that's probably an addendum. But the present models are more minimal and structureless. They can be thought of as abstracted versions of a surprisingly wide range of types of mathematical computational systems, combinatorial, functional, category. Okay, whatever. In what follows, section 2 through 7 describe features of our models without specific reference to physics. Section 8 discusses how the results from the preceding sections can potentially be used to understand known fundamental physics. Bro, I don't give a fuck about physics. I'm just in the world, living in it. Wait, which one said 1 month? Oh, yeah, bro. That's actually hilarious, dude. Okay, I guess I can coast for the next fucking month. Oh, yeah, that is hilarious, dude. That is so wildly off. I did it in 45 minutes. And most of that was goofing off and moving my monitor. Okay. So, what we want to do is... All right, so I will also create this. Okay. The following is the graph from the above picture. Okay, so yeah, so It has 7 vertices, so g dot add vertices 7. G dot add. Okay, wait, I don't remember exactly. So the edge set is going to be 1, 2, or shit. It's going to be 0. Dude, rush should be 1 index. 2. So 0, 1, 2. Then E2 is going to be 2, 3. Then 4 is just, or wait. So it's going to be 0, 1. What's the third edge? Oh, okay. It's going to be 3, 5, 6. 3, 5, 6. Then 4 is just 4. So we have 1, 2, 3, 4 edges. Is that right? 1, 2, 3, 4. Okay, perfect. So, 0, 1, 2. 2, 3. Fuck. 3, 5, 6. And 4. G dot add edges. What am I doing, bro? Can't type today. Wait, actually, maybe that's a little bit too. Oh, wait. Oh, you have to do it on all of these? Come on, guys. Okay, so we're good. The derived traits is probably one of the other great features of Rust is like, yeah, most of the time I don't want to go in and implement my own freaking debug. Like I just want to print it out. Is that so hard? Whatever. All right, so that's what that looks like. I think that's probably right. I can't imagine that it's wrong. Let's see. The length of this 1, 2, 3, 4, 5, 6, 7. Okay, so that seems wrong because 7. Oh, wait. Wait, yeah, something seems wrong. Because this should be empty, right? Okay, so the first guy, the first vertex only appears in 0. So that's right. Then the second vertex appears in how many edges? 2 edges. So it's 0, 1. So this seems wrong. Oh, wait. Yeah, that seems wrong. I don't know. Oh, you know what? It's probably an off by 1 thing. It probably is an off by 1 thing. What the hell? 1 line of code per day. But it's a really good line of code. So, can you really say? Can anyone really say? Okay, so, all right, then vertex, the third vertex has 3 edges. So it should be 0, 1, 2. Then the fourth vertex, or the fourth vertex should just be 3. And the fifth vertex should just be 2. And the sixth vertex should also just be 2. And then 7 should be empty. So somewhere we did this wrong because it should be. Okay, so. Okay, so it is this. I hate that. Should be. Okay, I'm just gonna put the triples. If I put the triples, does it? There we go. 0, 0, 1. Uh, yeah, 0, 1, 2. 3, 3. Oh wait, 3, 2, 2, none. So let's see. Oh wait, let's write the. No, 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 no. That's not it at all. That's not it, bro. You got 3 viewers right now? Bro, I'm the best. I'm the fucking man. Oh, I got a follower. Thank you, Zach. Okay. Uh, wait, this is just wrong, dude. Oh, the. Why does it have 7? This is not the. No, bro, this guy is so stupid. Okay, let me just read the code. I don't actually see. We need to add the remove edge stuff too. Dude, this is so easy to write. It's crazy. I mean, I bet that's all right. I don't really care about performance. We're not making million node graphs. Okay. So we did the remove edge thing, but we need to figure this out. So let's just. Did I just miswrite these? Oh, you know what? I probably did miswrite those. They're probably not 3, 5, 6. They're probably. Wait, I think they are 3, 5. Oh my gosh. One indexing is so obviously superior. So this should be 4, and 5. I knew that code didn't look wrong. So wait, did I get the other ones wrong? Yeah, so this is supposed to be 0, 1, 2, 1, 2, then 2, 4, 5, 3. Okay, so, bro, what the hell? Are you kidding? Found a documentation, bro. That prevents compilation? Are you kidding? Yeah, that's the most horrendous thing anyone could ever do is use 3 parentheses. Makes the compiler fail. Can you believe that? Okay, that looks right. So now we have the general hypergraph data structure. The next step is to start doing this graph pattern matching. I wonder if we could have a I wonder if that works though, because that probably assumes um um the okay. Oh wait, should I put this here? A note about the structure is that you cannot have vertex 3 without 2 and 1 at least being considered empty, not included in any hyperedge. So, yeah, so there's no holes, which is kind of interesting. But maybe we should have this method. Because I do want to be able to just click this and parse it. So this is not right. So let me just comment this out before I use it. Okay. So let's actually do a commit. Okay. Read. I don't even need. I just need the readme. Okay. Initial hypergraph data structure. Oh yeah. To do well. You know what? But the type system of Rust is different. So, although you probably weren't here at the time, but so I was going back through my old code, and I did this cool thing with the type system of Julia to figure out. Wait, this is the wrong thing. To try to take a module of a Julia, and you make for each vertex you have for each type you have a vertex, and then the methods defined within the module are the hyper edges. And so it's just like a cool way to think about the structure of a code base. And then I got weird, and I was like, oh, but it's actually a simplicial complex. I don't remember all that. That stuff I forget. But like the general thing uh of this is interesting to me. Okay, so now we can commit this. We can do a GitHub hypergraph rewriting RS. Okay, so now we'll get into it. I'm gonna go pee. I'm gonna get some fruit too. I should probably eat lunch. I'll make some lunch. Got a PB&J. Should be about 20, no, maybe about 20 grams of protein. Oh, such a mess, though. I got a napkin. Okay, so the way that I think about this is it's like the left-hand side describes, it doesn't, it's not necessarily just a graph, though.
Hey.
What's up?
Uh-oh. What's going on here? That's the high school. Yeah, it is. Yo, what's up?
Big bite.
Eating during eating disorder May? That's crazy. Fuck that, man. You get so skinny during eating disorder May?
Yeah.
I'm hanging the fuck up. Bye.
You should go to the gym with Cassidy. That would be so cool.
You can. If I get sexy, I'm leaving your ass.
Fine, but you'll be healthy. That's a good part.
Okay. Did you have something you wanted to say, or we just calling to say hi?
Is it close to Hastings?
The gym?
Yeah.
I probably have to go home and shower. There's one in Burlington and there's one in Waltham. I prefer the one in Waltham, but like they're not far.
Do you go home first though?
Me, yeah. I typically go home and do dinner and then I go to the gym.
Oh, okay. How late does it? When did it close?
They're open till 11. The one in Danvers is open 24 hours a day.
Oh, that's clutch with the 11. This one closed at like 9 that I go to.
Oh, well, the one in Danvers is open 24 hours a day.
Well, that's too much for me. I can't handle all that.
One time I got drunk and went to the gym at 3 in the morning.
That's great.
Crazy experience.
Have you seen that video of Alex Jones and Andrew Callahan just pounding tequila and getting on the bench? It's so funny.
They're just like me. Best pre-workout is tequila shot. Alright, love you. I'll talk to you later when I drop Cassie off.
Okay. See ya. Bye.
Bye.
I'm my shooters. Oh my. Ellie at another couch now. Oh my. Bought my mama that new house now. Oh my. Now she cannot kick me out now. Oh my. Dude, these peanut butter and jelly sandwiches are a freaking mess. But, you know, I needed a long stream. All my streams are like an hour. I'm like, what am I doing all day? This is really interesting that the pattern variable or the symbol on the left hand side, the fact that it's not distinct. Like, how would you want to enforce X and Y not equal to X? Like, you must be able to put that in there too. I remember I downloaded the book of this, the PDF, and I was on a flight and I was reading it, and I found a bug in the but the online version was totally fine. Drove me crazy because I was like, thought I didn't understand the theory, but it was actually just a bug. What if you just look up pattern matching on graphs? Graph pattern matching is a generalization of string matching. Okay. Bro, they use big words, but Is there a quantum graph isomorphism? Bro, that's kind of cool. What's the cost time of the algorithm is polynomial? Dude, why the hell didn't I know that? What is the algorithm? I don't think I'd be able to read it, but like that looks like a loop. I don't know. Polynomial graph isomorphism sounds pretty nice. Whatever. We are not going to be doing that on this computer anytime soon. I feel like this is in direct conflict with this archive paper. I never understood this. Wait. Oh, exp. I missed the exp. I was like, wait, this seems really fast. Dude, I don't. Bro, is that not a beautiful starfish? It's not a starfish, but a beautiful fish. You know what? Why am I doing this? I mean, this would be so cool if we had polynomial time graph isomorphism. Pattern matching would be easy. Oh. Okay. Why am I reading this, dude? I'm not going to understand that. Okay. Damn, I am exhausted. Maybe I'll go upstairs and do this. Can we just look at these graphs for a minute? What does that mean, binomial trees? Why is it a finance thing? I just want to know what it... What the hell? I don't know. That's so cool. So when you have XX, implies that X matched is equal to X matched. Or, yeah, the second X. Oh yeah, it makes a binary tree. You can definitely have multi-edges with the current setup. Rules can involve several copies of the same relation. So cool. X to... Wait, what? Okay, so there's two new vertices, and then there's yeah, so it does, okay, it does make a multi-edge. Okay, but it goes away. I don't know how they did this layouting thing. All right. So the way that you write rules, the examples we discussed all contain only relations involving two elements, which can readily be represented as ordinary directed graphs. But in the class of models we consider, it's also possible to have relations involving other numbers of elements. What the hell? There wasn't a single drawing. There wasn't a single drawing. What kind of crap is that? I think this time I want to go the full way and have the matcher be able to do multiple edges on the left-hand side. All right, where are we? Oh, good. No frame drops, or very little. Like, this is a tough drawing to make, bro. I don't know how I'm gonna. I think I'm just gonna output edgeless as a string to be able to make the list to plot in Wolfram, because I don't think I'm gonna be able to do it. Oh, that's an interesting one, because this hyperedge does not include that multi. Yeah, so it's not even really a multi-edge. This doesn't really have a multi-edge in it. It just happens that you can decompose it and find that if you were to treat every, yeah, whatever. In a sense, there's a multi-edge, but there's not really a multi-edge there. Brother, why do they make such a weird ass drawing? It's so cool. It's worth noting that in addition to having relations involving 3 or more elements, it is also possible to have relations with just one element. Here's an example of a rule involving unary relations. Ha 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 ha. Okay, this is where I think I gave up. But basically what this is. Yeah. Yeah. This means that all the rules we've seen so far always transform single edges or hyperedges independently. But consider a rule like that. XY and Y and XZ goes to XY, XW, YW, ZW. That's fucking awesome, man. And then you just leave that guy out. Okay. Or y to 3, z to 4. Yeah. How many matches are there? There's probably a ton of matches. Okay, so if you have 1, 2, 3, 4. And you had the pattern X, Y, Y, Z. And you could match 1 to 2, 1 to wait. Oh no, yeah, it's XZ. You could also just pick the other guy. Right. With a rule that depends on a single relation, there is an obvious way to define a complete step in the evolution of the system. Just make it correspond to the result of applying the rule once to each relation. When the rule involves multiple relations, we've seen here that there can be ambiguity in how it is applied, and one consequence of this is that there is no longer an obvious, unique way to define a single, complete step of evolution. For our purposes at this point, however, we will take each step to be what is obtained by scanning the configuration of the system and finding the largest number. Oh, I don't know if I implemented that. That seems hard. I kind of doubt that I did that. Wait, that seems really hard. For our purposes at this point, however, we'll take each step to be what is obtained by scanning the configuration of the system and finding the largest number of non-overlapping updates that can be made. In other words, in a single step, we update as many edges as possible. We have seen that there can be several ways to apply a particular rule to a configuration of one of our systems. It is also possible that there may be no way to apply a rule. This can happen trivially if the evolution of the system reduces to the number of relations. Yeah, at some point there's simply no relations yet left. Yeah, bro, I love that. I love that. You just don't know what it's going to do without running it. I love that. I love that so much. Does this just copy as literally that? Uh. Okay, so here we have and the rule is okay, yeah, that makes sense to me. But it's different than you think because what actually happens is that yeah. Rules whose left-hand sides are connected operate locally on hypergraphs. Oh shit. Yeah, that's a crazy rule actually. Yeah, it's a oh wait, I'm a little loud. Yeah, it's a hypergraph and it's doing rewriting on hypergraphs. So you have some pattern. It's very it's very similar to the Mathematica. I gotta cut my nails. Okay, all done. How long has the stream been going? Alright, yeah, see you, bro. I was thinking about ending it too. 2 hours in. We wrote the library, now we just gotta figure out how to do the pattern matching. Dude, this is so sick. Oh my god. 2 3s and 2 2s. Yeah. So, but in systematic studies, it's often convenient just to use integers to represent elements and rules, even though these are still to be considered placeholders or pattern variables, not specific elements. It's important to note that there's a certain arbitrariness in the way the rules are written. The names assigned to elements in general, determining whether two presentations of a rule are equivalent is essentially a problem of hypergraph isomorphism. Oh boy. Oh, you can actually read the code. How many lines of code is this? Well, it's impossible to say because it's literally a fucking mountain of expressions. So we have no idea. Oh, dude, that's so sick. What? What the fuck is that? That doesn't make it. That's crazy, bro. Tuple index. Dude, I I don't know. Yeah, that makes sense. Okay, so even though I don't understand the thing about the how they generate the rule number, it does make sense that it's not dense. The canonicality, canonality, canonical, canonicality. What the? Oh my god. Oh yeah, I wanted to look at this. This is what I was looking for earlier. Ooh, random universe. It's so general that oh, I love that they have that. That is so cool. I have no idea what they mean by it. Layered causal graph. Neighborhood volumes. Oh, what does that mean? Ooh, that's cool. You can do random. Oh, that's so cool. I mean, I would be curious to know just what are the with normal graphs, not even hypergraphs. Like what interesting behavior can you do? Oh yeah, that's given it. Okay, so the number of possible rules, enumeration. This is the stuff I love. Given a particular signature, one may ask how many distinct possible canonical rules there are. I mean, you could ask the total number, but the yeah, whatever. Dude, that's so cool because it's literally unlabeled versus labeled. Yeah, so you want to know the number of canonical. As a first step, one can ask how many distinct elements occur in the rule. What does that even mean? Oh, yeah. The maximum conceivable number of distinct elements. Yeah. Bro, that's crazy that there's... I mean, maybe that's not crazy. 560 rules? Oh, it's so cool. Yeah. What the hell is a bell number? Oh. Partition. Oh, wow. Sick. There should be 2, right? What? Wait, they hallucinated that? Did they misspell it? Oh. Okay, so there's 2. Okay, so those are the bell numbers. Whoa. All right, I am freaking exhausted. I'm peace out. We'll do the rewriting of at least basic rules, meaning single relation on the left-hand side tomorrow. Peace.